on the webinars here at Hosting. Today we're going to be covering continuous security on AWS. With me I have Chuck Dudley, who is the VP of Services at Stelligent, a division of hosting that specializes in DevOps automation, particularly on AWS. Before we dive into the presentation, though, I'm going to cover just a little bit of housekeeping. This webinar is being recorded, and an on-demand version will be available at the same URL at the conclusion of the webinar. You can submit any questions you have via the button on the bottom left of the viewer, and if we don't get to your question during the webinar, we are happy to follow up with you via email. You can download the PowerPoint slides via the attachment button below the viewing panel as well. And if you're on Twitter or LinkedIn, be sure to follow for news, resources, and announcements for future webinars. At this time, I would like to pass it over to Chuck Dudley. Chuck, thank you so much for joining us today.
Thank you, Chelsea. So today we're going to talk a little bit about continuous security in the AWS cloud. Continuous security is really a very simple concept. It's the concept of performing security, securing your environment through the practice of continuous delivery. With the DevOps culture that we're all moving towards nowadays, it's a perfect opportunity for us to treat our infrastructure as code, and as we're doing that, we're able to apply modern development practices such as continuous delivery to producing our infrastructure. And really, the principles or the tenets of continuous security are, in fact, the same as continuous delivery. And I'm not going to, if anyone has worked with continuous delivery, they've probably seen a variation on this slide that we're looking at now. And I'm not going to go through the entire thing, but the idea is that continuous security has all the same earmarks that continuous delivery does. The idea that you automate everything, particularly your security, that everything, including security, is code, that you iterate and improve on your security continuously, just as you do, in a development practice where you're actually pushing code out to production. So I mentioned just a minute ago a DevOps culture, and we really need to dive into that because that's fairly critical to what we're doing here and how it operates. DevOps is, a lot of people look at it and say, oh, that's development plus operations. That's really not true. What DevOps is a cultural movement or a cultural approach to delivering business value where you gather together into an autonomous group all of the stakeholders that are involved in being able to deliver a change to code, infrastructure, a new business proposition into production, such that you don't have any wait queues, you don't have any delays looking for permissions, and you're able to move forward rather rapidly. And again, the important thing is that it's not just development and operations, but all the other stakeholders, QA, security, all those organizations within an enterprise you might have to go to for permission to deliver some code into production are all collected into a group so that they're interacting together and they can make those decisions without weighing, without reviews, without approvals. Continuous delivery is really a practice, a modern development practice, where we build software in a way that it can be delivered into production if you so choose at any time. Every single time you make a change to code, your application is fully tested, fully vetted, analyzed, and is brought to a position that it could be delivered into production if you so choose. If you actually are doing that in an automated fashion and it just automatically flows into production, like a number of organizations such as Netflix do, that's called a continuous deployment. But in continuous delivery, we are prepared and have the means to deliver into production code in a completely automated fashion, simply at the press of a button. on my screen now is a very, very basic continuous delivery pipeline. The idea is, as I mentioned before, every time that we make a change to code, any kind of code, whether it's an application code, whether it is infrastructure code, CloudFormation, Terraform, Ansible, Fugue, whether it's your tests that analyze the validity of your application or your infrastructure, or even security policy. All those things are represented as code. Whenever there's a change to that code, there is an automatic process of building whatever is necessary to be able to validate the change that was made, performing the tests on it, and then being able to deploy if you choose to. It's the hallmark of the pipeline is that everything moves through it in one direction, that there are essentially test points or validation points along the way, and as soon as something doesn't pass the test, it doesn't meet the ideal that you've defined in your written tests, the process stops, people are notified, and everyone jumps on fixing the pipeline, making the pipeline go green, as we refer to it. Now, here at Stelligent, we focus a great deal on continuous delivery. We do lots of work in that area. And we have a little bit more granular view of the continuous delivery pipeline. Now, you might say, why would you do that? Why would you, look at it, having more stages than just simply build, test, deploy? And the answer to that is that one of the fundamental features of continuous delivery is the idea that you need to give very rapid feedback to your developers, those people that are writing code, making changes to code, whether it's infrastructure code or application code, so that they are not sitting around waiting a long time to get an answer when they could find out much more quickly that they need to iterate, that they need to improve their code. So the way that we help to drive this rapid feedback to developers is to break the pipeline up into different stages, and those stages collect tests that would run, typically speaking, at different speeds. The pipeline stages that we typically define are commit, acceptance, capacity, and then going to production. Pre-prod, where we're actually building an environment that can be moved into production, and production, which is the swapping of the new production environment for the old production environment. Now, the commit stage is the fastest stage. We literally strive to get answers back to developers about the quality of their code in seconds. When we're talking about your classic continuous delivery, a practice that's been around for quite a while, the kinds of activities you would see in a commit stage of a pipeline are typically things like unit tests, static code analysis. You might lint code, very simple tests, kind of sanity tests for the changes that you make to your code in the form of unit tests. But when we start to apply security to the commit stage of the pipeline, we start adding additional kinds of tests. So in one case, if we're thinking about the application, one of the things you might do is add security static analysis of your application code. And there are many different tools that you could use to do this, almost as many as there are different languages that you can write code in. Examples, Brakeman, Flaw Finder, and many, many others allow for the analysis of code before it's actually compiled, turn it into a jar or whatever your process is, in order to understand if there is a risk associated with that code. But since we're approaching things, as I mentioned earlier, with infrastructure as code, we want the idea is that everything is code. We also want to be able to do security static analysis of infrastructure code. In fact, I would posit that it's maybe more important to do security static analysis of infrastructure code than it is application code. The reason being that your application, if there's a security flaw in it and you don't find it before you actually compile the code, your next stage is typically very much a sandbox environment, and the risk is highly mitigated in that situation. When you're working in a public cloud, like the AWS environment, though, and you have infrastructure code that might be setting up security groups or NACLs or other security aspects, buckets. All these resources are internet facing. It's a public cloud, and you have the potential, if you make mistakes there, that you're putting yourself at much greater risk. So it's a much higher value to actually be able to analyze the code that's going to create cloud resources before those resources are created, to stop yourself from being put into a compromising situation. When we started developing the continuous security pipeline, we went out and looked for tools to do just that, to give us static analysis of infrastructure code. And because we're working in AWS, the primary tool for infrastructure code is CloudFormation, an AWS service. We were unable to find any tools that would actually analyze the code and tell you and try to predict for you what the security weaknesses of that code might be if those resources were instantiated. So we went out and wrote a tool. There's a tool called CFN-NAG. It's an open source tool that we produced. Anyone can use it. And again, is do a security validation before creating resources, and really to stop bad things before they happen. Some of the kinds of things that you might check for if you're doing security static analysis of CloudFormation, or in fact, any other tool you might be using for infrastructure provisioning, over permissive IAM policies, over permissive security groups, disabled access logs, or the absence of logging, disabled server-side encryption on S3 buckets, on or other EBS volumes, things like that. So all these things can be checked, and literally can be checked within seconds if you're using continuous security. If you're applying security to your continuous delivery pipeline, and give developers immediate feedback. One of the really nice things about this is, at the same time it's telling them whether or not they have to go back and iterate on their code, it's also improving their knowledge of what makes good security as you're writing infrastructure code. And obviously this is valuable because the more you iterate, the more you write this code, the better you get. And a core tenet of continuous security is that it's not just the security team that gives approval that's responsible for security, but everyone in a DevOps team, everyone in your autonomous team that's delivering value is really responsible for security. So the actual process of using tools like this makes the team, makes the employees that are dealing with infrastructure code better at security as they go along. So the next stage, once we've analyzed the code, and literally at just a few seconds, and we've given answers back, everything is green, everything looks good, is called the acceptance stage. The acceptance stage is where we actually do testing on the application itself and whatever infrastructure is necessary to support that application. And when I talk about the infrastructure associated with the application, we're not talking about the full-blown production environment. That's going to take much longer to spin up. But for instance, if you've written a web application, you're going to need a web server and perhaps an application server to run in order to be able to test it. So that's what I'm referring to here. And in this case, you typically, in a classic continuous delivery environment, are looking at performing integration tests and acceptance tests. Tests that really look at the basic functionality and see if the application and or the infrastructure that is supporting it is really doing what you expect it to be doing. When we start looking at adding security to the pipeline, in the acceptance stage, there is a very valuable activity that can occur in the stage called infrastructure analysis. Now, it's true that in the commit stage, we have in fact looked at the code and tried to determine if there are any security flaws in it, and we get a pretty good idea, but we really can't tell for certainty on all aspects, there are just some things when you're creating resources in AWS that you won't be able to tell by looking at the code itself. You'll actually have to examine the resources themselves. So what we're doing in this stage is trying to determine, as we create new resources in order to test our application, if those resources, if the creation of those resources are changing or are degrading our security posture of our environment. So why we're doing this, we want to certainly prevent infrastructure changes that violate company security policies. We're also codifying, turning into code the security rules and causing notifications to be deployed when violations occur. And we also need the ability, there's a lot of tools that will give us this ability that will go out and scan your environment and tell you got 73 security groups that might have too broad permissions, things like that. But again, some of those tools even are services that AWS offers, like Config, that can help you with that. But in terms of actually analyzing it in the context of a continuous delivery pipeline, that's a little bit harder to do because it really requires the ability to do on-demand testing and to have immediate feedback of the results of that testing as you go along. Again, a tool that we wrote that's open source that can be used if you're using Config to analyze your security posture. It's called Config Rule Status, and it, at the heart of it, it uses AWS Config Service. But what it does is it through Lambda functions, through the serverless framework, and other tools, it actually sets this up such that it can be deployed, tested, and validated in the confines of a continuous security pipeline, so that you can get that immediate feedback as you spin up those new resources, immediately be able to test and determine if there's been a degradation to your security posture. If we make it through this stage, we're looking pretty good. We've got code that meets all of our standards. It's linted. The security testing of the application and the environment, that all looks clean. We've analyzed the infrastructure environment, the AWS account itself, where we made these changes, and we've determined that those changes do not pose a risk at this point. So we're able to go on to the next stage. The next stage is called the capacity stage, and this is where we get into much more heavy-duty kinds of testing. We're really doing real-world testing. We want to validate that if this application goes live, if this change goes live, that we are going to be able to support our traffic, support our customers in a real-world situation. In a typical or a classical pipeline, some of the things you perform here are performance tests and load tests. You might also perform chaos testing in order to determine if bad things do happen, if machines break, if systems go down. Does your service degrade gracefully, or is it resilient enough to continue delivering services? So there's a lot of different activity here, and because when you're doing particularly load tests and performance tests, this may be very long-running tests. You may do soak tests that run for hours and hours to see if there's degradation of service as the requests pile up. When we're looking at security, there's a couple of other kinds of security tests that can be performed in this capacity stage. Again, the capacity stage, we've created an environment that looks like what we're going to deploy into production. And if it's close to that, if we're actually building the load balancers, the web application firewalls, all of the tools around that would represent a production deployment, we can also perform, for instance, penetration testing, automated penetration testing, in order to assess the risk at making this code change go live. We can do vulnerability scanning on the systems that we're putting out into production ahead of time. All these things can give us the ability to have a real understanding before we ever get into production of the security risk involved in promoting change into production. So penetration testing, first of all, there's a couple of different kinds of penetration testing that can be done. One particular type of penetration testing is, a lot of companies, either they have requirements or regulations that they do regular pen testing from outside organizations that, really they have, it's like an attacker actually going after their system in order to assess weaknesses in it. The other kind of penetration testing that you can do is much more automated testing that you can do internally. One of the things that we like to do in the continuous security pipeline is from within the VPC, so that you're not affecting other customers on the AWS shared infrastructure. You're able to do things like OWASP, ZAP, or Nessus or Metasploit testing in order to validate the security of your application and the infrastructure that it's riding on. As I mentioned here, automated penetration testing from within a VPC is okay. It's automated penetration testing from outside the VPC, where you need to go through the process of getting permission from AWS to perform that kind of testing. Okay, and so we've now gone through the commit, the acceptance, and the capacity stage. We've analyzed our code in the commit stage, and the security of it looks good. We've analyzed the application and its immediate infrastructure in the acceptance stage, and we've still got a green light. We've analyzed the environment that we expect to promote into production in the capacity stage, and gone much further, much deeper into the analysis of both its resiliency as well as the security of the overall infrastructure, the architecture that you're planning to put in production. So the final stage is what we call the production stage, which is composed of two phases: pre-prod, where we actually create an environment that will get promoted into production. And we validate that again to make sure that we're ready to go. And then the final act is the promotion of that environment into production, the swapping of it for the old production environment in order to get the change live and into production. So the kinds of actions that we do here is, as I mentioned, first thing we do is we build the pre-prod stack, the environment that we propose to push into production. We might do data migration if that's required in certain areas. And then some means of actually swapping environments. We've described here blue-green deployment, which is most typically the most significant or the most often used method of swapping environments when you're making production change. But there are other methods, canary method and others, red-black method, in order to get a new environment into production. So when we add security testing into our pipeline in this final production stage, what we're seeking to do here is, we've already done all these tests along the way, but again, when you're in the public cloud, when you're providing resources, in AWS or other clouds, your code certainly is making changes to your environment. It's spinning up resources, it's spinning up instances, load balancers, it's creating security groups. But there's always the ability, even though you should strive to avoid it, there's always the ability for people to make out-of-band changes that don't come through code. So we have to be constantly vigilant that our environment, the security of our environment, doesn't degrade as time goes along by people making these out-of-band changes. So all the testing that we've done, particularly the testing that happens in the capacity stage, and a significant portion of that happens in the acceptance stage, isn't a one and done kind of testing, but it's testing that continues to operate and continues to evaluate the environment that we produced as it's swapped into production, so that we will get a red flag, we'll get warning as soon as an out-of-band change has been made that degrades our security. So the idea is that this security is applied as code during the development process and vetted then, but it continues to be continually revalidated in our production environment, so that we can make sure that we have not become susceptible to attack. Another feature that is fairly important in this final stage is that as we collect information about the changes to the environment, either out of band or otherwise, in this final stage, we're getting metrics out of that. Those metrics can feed back into our development process. As long as we're logging this and analyzing it, we get valuable information that goes back to the developers that tells them, as they continue to iterate on the code, as they continue to improve it, how they can make the security more valuable, how they can dynamically change in order to be able to address the changing world of attack vectors that present themselves in a constantly evolving basis. So the config rules that we talked about in the acceptance stage, when we utilize this tool in the continuous security pipeline, continue to operate. That rule set stays in effect, not just for the environment that we create and analyze in the acceptance stage, but continues to be applied so that we, as we move into production, so that we know that the environment maintains the rigor, the security specification that we have established at the beginning, so that we know that we're not backsliding, that we're not seeing out-of-band changes that are causing us a security degradation. The important thing to us is that the testing and validation criteria that you use in order to decide whether or not to promote code, infrastructure code, is important in terms of your operational monitoring. Quite often we see a dichotomy in the development and operations world, where there's one set of tests that's applied during the development process, and there's an entirely different not only set of tests, but even set of tools that are applied at an operational level to validate. It's important that those two tool sets come together as we're bringing our developers and our operations people together into a single team, such that the view of security, how to improve it, how to protect it, is consistent from the development process through into the production process. And that's really what we're striving for here with continuous security. So there's a few key takeaways that I want to cover here. The first one, we've talked a lot about infrastructure as code, and this is really critical to us. Your infrastructure nowadays, particularly in a public cloud environment, is code. We need to treat it as such. And as we treat it that way, we find that applying modern development techniques such as test-driven design and continuous delivery yields immense value to having a secure infrastructure environment. And also, now that infrastructure is part of the solution in application development, it should be the development of infrastructure code should be integrated into the application development process. There's no longer a reason that we need to have one team that operates in isolation that builds our systems and defines firewall rules and hardens operating systems, and an entirely separate team that that really never talk together, that handles the application code and the securing of it. In the DevOps culture, we want these people to be working as a single team, as a single unit, be able to deliver business value without having handoffs, tossing product over the fence to another team that then has to deal with it. So we really, really want to get into a situation where infrastructure development is done hand in hand in the same team together with application development. So, and then finally, to wrap up, so from within the development team, this continuous security process and continuous delivery that I've talked about, it reduces cycle time. It gives developers very rapid feedback. They can iterate much more quickly on their code to improve it. The feedback that they gives them educates them, makes them better at security the more that they do it. But an interesting thing happens if we take a different perspective. If we look at it from outside of the development organization at a much higher level, by expressing our security requirements as code, by developing these tests and having this very unambiguous bar that you have to meet in order to promote code from one environment to another. What we've done is we've given ourselves the ability to inject security best practices as automated gates in the delivery process without creating delays for review and approval by a small and perhaps overtaxed team of security specialists that have to come in and manually validate security or make decisions about what represents good security and what doesn't. What this does is it allows a relatively small security organization that adopts these principles to control and secure a public cloud environment at scale across literally dozens, hundreds, thousands of development teams without grinding to a halt, without becoming the constrained resource that prevents the applications from being moved into production. So Chelsea, that's all I had on the topic. Do we have any questions?
Yeah, let's run through a few. And if you are viewing the webinar currently, you can submit any questions you have about Chuck's presentation right now, the bottom of the viewing panel. But I'm seeing one. I have heard about auto remediation of security issues. Is this a good practice? Thank you, Chelsea. That's an interesting question. It's something that's actually near but not so dear to my heart. From our point of view, auto remediation is an area that presents a lot of risks to the preferred method of doing security as far as we're concerned. And I know that may not make immediate sense to people, but here's why. So if we're representing our infrastructure as code, then the security of that code, is in essence embedded in that code. If we're doing auto remediation means that there are processes, quite often like Lambda functions, that are constantly analyzing the security validity of your environment and then making changes. For instance, it'll tighten down a security group. There's a port opens on a security group that shouldn't be open. It will shut it down and just goes through and does those things. The problem with this approach, from our point of view, is twofold. One, from a very practical point of view, if your infrastructure is code and if you've got a separate process that's now ongoing, making changes to the AWS resources themselves, then your single source of truth is no longer your code. In fact, you cannot look at the code and understand what your actual operating environment is. So it creates this division, this separation where your code doesn't tell you what's actually out there, and if you use that code again, then you're going to have changes that are going to then be auto-mediated again. So that's a very practical problem. From kind of a philosophical or cultural approach, and an important thing to understand about
the DevOps process and the continuous delivery process is that as problems occur, it's not individuals that are reacting to them solely. It's a team. It's a group. We're constantly trying to raise knowledge to an organizational level. If someone creates a weak security group, and we're using this continuous delivery process, what happens to something called stop the line? The pipeline goes red for that piece of code, and it will not go green again. In other words, nothing can flow through the pipeline until that problem is fixed. So it becomes very public that there's a mistake, that there's a problem. People learn from that. People react to it and fix it. And as I mentioned, a very valuable aspect is that they essentially are learning, are improving their understanding of security as these things are pointed out. With auto remediation, what we actually see happen in a lot of customers that we work with is that if they're using this, the developers aren't learning anything at all. They're writing bad code. This automated process goes behind them and fixes it. There's a difference between the code and what the actual environment is, and no one has learned anything. There has not been this promotion of knowledge of problems to a higher level in the organization where it becomes clear to all, hey, this is a bad practice, we should never do this. So should you never use auto remediation? No, I wouldn't say that. What I'd say is that if you do use it, you have to be extra vigilant, that you really are focusing on the cultural aspects of continuous delivery to ensure that when these things do happen, when there's a difference, that you continue to react to it at the code level, not just let the auto remediation be the solution to the problem.
Good deal. How do I deal with operational security issues that might require immediate manual action?
Okay, that's actually a pretty tough question, and I say that because from our point of view, philosophically, we like to say that nothing needs to be manually remediated. That everything, because in essence our infrastructure as well as our application starts as code, that there's that we always want to make the change at the code level. Not into the operational environment, so that we don't have that division between what the code represents and the operating environment not matching it. So in most cases, we really do promote wherever possible that we use an immutable approach to infrastructure. That if there are problems, systems get taken out of commission, new systems get spun up to replace them, and that this process is all coded, scripted, so that it happens automatically as tests determine that there are problems. But there are always situations where people say, no, I have to react too fast. I have to shut down the system. I have to take this immediate action on a security group, whatever. So we can't say you never do that, but your process of doing that has to do two things. One, it has to make sure that whatever manual activity happens flows back into the code. In other words, in order to make sure that this doesn't happen again. And the other thing you have to do is you have to look at the process, not just the error or the vulnerability that occurred, and fix that, but you have to look deeper at your development process and what allowed this to happen, and make sure you're addressing that. We tend to talk about the idea of focusing on fixing the process over fixing the product. In other words, fixing the process that allowed a weakness or an error to occur is of much higher value to your organization than simply fixing the product and therefore having the possibility of the process generating a similar problem with a different product or the same product later at a later time.
Perfect. I can see this approach working with new cloud formation stacks, but what about when you need to do, when you need to update the stack?
Okay, so again, that gets a little bit back to, in a way, the idea of an immutable approach versus mutable operations. We tend to prefer to avoid the idea, if you're working with CloudFormation, and again, for those that aren't familiar, CloudFormation is a resource provisioning language or service on the AWS cloud. But we tend to prefer to utilize a capability called change sets when we're using CloudFormation, as opposed to doing update stacks. And maybe I should give a little more context. So if you're using CloudFormation, you write your code that represents the resources you plan to create, and then you do an operation called create stack. And the create stack actually reads the code and creates the resources according to the specifications of the code. And then this thing, the collection of resources generated by that activity is called a stack, and it's sitting out there and it's looked at as a unit in the AWS environment. If that stack needs to change, there is a function called update stack, which then goes in and makes changes to that stack. And the problem is that it's kind of opaque what is really happening when you do an update stack. And it's opaque because it's not immediately obvious what resources get changed versus what resources get deleted and new resources get created when you're doing that, because there's a lot of dependencies involved in it. So there's a capability with CloudFormation called change sets. And what happens when you use that capability is, rather than doing a stack update, an update stack function, you do something called create change set. And create change set essentially analyzes your modified stack and then gives you a list in code of those resources that are going to be deleted, those resources that are going to be updated, and those resources that are going to be created. You can then run analysis on that and make sure that the impact, is what you expected. You're not deleting, for instance, a database in the process of making change that you're dependent upon. So we tend to prefer, as opposed to doing update stacks, to using a model where everything, whether it's a create stack or an update stack, a change set is created from it, and then that change set is processed. And it doesn't solve all the problems, but it helps with some of the complications and the opaqueness associated with the idea of doing update stacks in CloudFormation.
Perfect. I think that's all the questions we have for today. If you do have a question, you think of it later, you're always welcome to leave feedback for us, and we always get those questions over to the presenters, and they can answer up with you personally. But I think that concludes then the rest of the Q&A. Chuck, thank you so much for joining us today and providing really excellent information about continuous security on the public cloud, particularly AWS.
Oh, thank you, Chelsea, and thanks everyone for attending. Please do feel free to send questions in. Be happy to answer them. We live and breathe this stuff, and it's a passion of ours. So no question will go unanswered.
Good deal, Chuck. All right, thank you, everyone, and have a great rest of your afternoon.